So now we want to create the pattern for a bridge, for a mandibular bridge. It's going to be metal ceramic, and as always we mark the margin. Now if you look carefully, this seems to be blue. That means indeed it is, the pencil is wax. Actually the tracer is wax, so it marks the margin. This is important because in principle we want to avoid carbon. Carbon may impurify the metal. Yeah, this is not such a problem for non-precious metals, but for metals containing gold that could be a problem. So if the marker is wax, it's much better, right? It doesn't impurify anything, it will be burned. So now this is the hardener, as we know very well already. Both dies are hardened like this. Of course, we wait for it to dry out, and now the margins, the sharp margins of the die are foiled with wax. So this is to create extra space for the perfect adaptation of the crown. You don't want it to touch there. You want it to touch only on the margin, on the shoulder. Actually, you see the preparation was done with a shoulder. It's a chamfer, medium chamfer, not deep, not shallow, not bevel, just medium chamfer. So now the technician makes sure that there's gonna be no interference between the coping, the metal coping, and the abutment when the bridge will be placed in the mouth. Same thing for the molar. And again, the wax that we use here is a wax that is melted at a very high temperature. Well, much higher than, yeah, some 10, 20 degrees, 30 degrees maybe higher than the other waxes that we're using, just to make sure that it will not melt during the other processes of creating the pattern, the wax pattern. Of course, it will be covered by a layer of spacer, which is some sort of a paint, but anyhow, we want to make sure that we'll have no issues with this. So with melting this wax with the other waxes that we use. So now that it has been foiled, this is a very, very important step. Only good technicians know to do that, and they're careful in doing that. Now, of course, once we're ready with both of them, we shall apply the spacer. The spacer, you hear something, there's a metal ball inside, just to prevent the separation between liquid and pigment. So 1 millimeter, 1.5 millimeter maybe above the preparation. We should say 1 millimeter, that's the best. Yeah, so this creates an extra space for the cement. Now about the space for the cement, well, we're gonna have another movie explaining this. It's a very delicate thing, and many a technician and dentist don't realize the importance of having enough space for the cement. By the way, what cement is the dentist using? Thick or thin? And this is very important to know. So you see carefully, and why not under magnification? Well, it's not absolutely necessary, but it's even better to do it like this. You just apply the spacer. Well, the technician applies the spacer, right? And on the top as well. We don't want direct contact there. It will be a contact, but with the cement in between when we cement the bridge. We don't want excess either. And once it's dried, we can start the isolation. This is absolutely the same as in all the situations. Whatever wax pattern we're doing, this is typical. So again, we introduce the dye in an angle, yeah, to allow the air to go out quickly, and then we take it out slowly so as to get a uniform thickness. This wax is very quickly melted. It's just like 85 degrees and it melts, so it's the lowest temperature for a wax to melt. Again, quickly, and then we take it out as if we took marmalade with a spoon. That's the movement. And now, as we know, we apply wax for the cervical region. We see by translucency where the margin is. So the spatula is really warm, hot. You want to feel that this type of wax touched the dye, the plaster. Yeah, actually it goes through the other one that we placed first, through the dipping wax, through the yellow one, and gets to touch the dye, the plaster. Right, so there we do the same thing for the canine. You see how important it is to have a nice preparation and well captured in the impression and well reproduced in plaster. If the technician doesn't see exactly where to close, then how can he or she do the job properly? So now again, the excess is removed, but the spatula has to be warm. For the main excess of wax to be removed, we have to have a warm spatula. Then the rest that remains can be removed in a dry or cold state. Yeah, but now we want to, because it's a lot, we want to remove it at high temperature. Again, the same as we have seen in previous movies. So in this way, the coping remains perfectly adapted to the dye. So now the two are in place, the two simple copings, as we call them. They're not ready for placing the ceramic because they should follow exactly the shape of the tooth, of the ceramic tooth, but they're ready to as copings, as simple copings. They're ready. We can start the build-up, the wax up actually. Yeah, the wax up. So you see we're waxing up, and the technician imagines where the final crown shall be, the final shape of the crown. So in correlation to that, it builds up, I mean the technician, in our case it's a lady, she builds up the metal framework so as to follow closely the ceramic that will be placed upon it. So yeah, this is not a canine, that's true. This is a first lower premolar. That's right. So you see, the morphology is taken into consideration. The technician knows exactly the morphology of this tooth, and you see it mimics some sort of underlining structure for the cusps and for the marginal crests. We would like to have ceramics at maximum 2 millimeters distance from the metal, 1-2 millimeters. Yeah, 3 millimeters, it begins to be too much. But we need to have also enough space for the ceramic. Yeah, so that's why the technician is checking in occlusion to see whether things go well and everything is fine. The ceramic should have uniform thickness, so that's why we follow the shape of the tooth with the underlining wax that will become metal eventually, right, by casting. Close to the gum, the wax should be quite thin. You want as much space for the ceramic as possible close to the gum. You wouldn't like the metal to shine through, or to give that grayish aspect to the gum, which often happens. Yeah, because there's not enough ceramic covering the metal there, or the ceramic is too thin, and the metal kind of shows through. Yeah, and then you blame the gum for not being thick enough. That's stupid. You have to create your space. Anyhow, it's quite difficult because it's metal ceramic, so metal will always create a problem, aesthetic problem, that's true. Okay, so now the wax is melted in surface to make it nice and smooth. As you can see, this is just alcohol and a little bit of a flame. Yeah, burning alcohol, and you just press and there's alcohol burning coming out and softening the surface of the wax. Here, for example, on the palatal, we need a little bit of support for the ceramic. So the technician is viewing mentally the future shape of the crown, of the final crown, and is following it at a distance with wax that will, as we said, become metal. Softening of the surface, and then cleaning, perfect cleaning of the margin. And after that, we will be able to remove the coping from the die. So the wax there has to be quite thin in order to allow enough space for the ceramic. So that's for the first premolar. Now it has to be taken out slowly, slowly, carefully. Of course, you don't want to press it and to damage it. That's it. So we check the perfect adaptation. Right, it's there. And if needed, some additional cleaning. And then we're going to do the same for the molar. So same thing here. Now, the space here is very limited. Probably it would have been way easier to do it in metal, full metal crown there. Because indeed there's the space is very limited. And it often happens. So, but let's suppose that the patient did not want to have metal seen in the mouth, not even there on the lower mandibular in the back on the molar. So okay, so the technician will try to put ceramic over the metal. Maybe in this case there's no need for adding wax. You can simply put ceramic directly on the simple coping. That's another discussion. We'll see in occlusion. Or the technician may suggest to the dentist to enhance the preparation, to prepare more, to create more space, if there is not enough space, if the technician considers there's not enough space for metal and ceramic together. Curiously enough, you know, this lady is bold enough to add some metal. I'm curious how much space she will have left in occlusion. Those are the cusps that give the first degree stops, occlusal stops, right? The vestibular, the labial cusps of the molars, of the lower molars. So that's first degree occlusal stops. And now we check in occlusion and wow, it's almost touching there. Now what? See, the ceramic needs a minimum thickness. If it's less than 0.8, then you have a problem. 0.81 millimeter at least. So now she'll start removing from this wax. Probably, oh no, well, okay. She softens it. And maybe she will see when the metal framework is ready. She will see the exact space that she needs and trim a little bit more from the metal. See, everything has to be round. In ceramic, we don't want the framework to have sharp edges because that could cause the breakage of the ceramic, could cause cracks in the ceramic. So now, if everything is cleaned at the margin, we can try to remove the coping, but yes, first we have to clean the margins. So everything has to be rounded, no sharp corners. So again, the wax over there should be thinner because we want to have enough space for the ceramic. Obviously, that's not an aesthetic zone, so that's okay. I mean, who's gonna look there? Right at the gum margin. It's a lower jaw. Should not forget that. But the technician wants to do things very well, and that's nice. That's fine. That's okay. It should be done like that. Round margins, as we said. And now the coping is removed from the die. Yes, it comes out easily. Nice and clean. A little bit of excess here and there, so this has to be taken out. Of course, if you use magnification, then it's going to be better, for sure. And the molar is ready as well. The coping of the molar with the wax up added so as to follow the future morphology of the final crown. Those are the pontics. They are also underdimensioned, and they will be connected to the copings, and the part that contacts the gum will be reduced because we want space there. We want only ceramic to touch the gum, not the metal. So the pontics don't touch the crest, right? It's only ceramic that touches the gum. And now we should just connect the pontics to the copings. This is the first moment, the first contact in between, and then it will be made way stronger because otherwise it could break. Even it's metal, it can break. The occlusal forces are very, very important and high. So everything has to be smaller so as to allow at least 1 millimeter of ceramic over this framework when it becomes metal after casting. So everything is round, as you can see. We say this again, and the technician is holding everything in place to make sure that when the wax contracts, it doesn't move anything. It doesn't move the copings from the dies. And this is a very challenging part of our job, you know, because the wax is quite strong in contracting, and at the end you will notice maybe that the whole thing does not adapt perfectly on the abutments because this connective wax has created some sort of contraction and displacements of the coping. So that's why you see the technician over and over again holds everything in place and blows air